Polyatomic ions are molecules, so they are comprised of more than one atom with an unequal number of protons and electrons, so there is an overall charge. A common mistake that beginning chemistry students make is to confuse the subscripts in the polyatomic formula with the charge. The subscript is different from the charge. Let's look at two examples here. The first polyatomic ion written has a formula of capital C, capital O subscript 3. That means that this polyatomic ion has one carbon atom and 3 oxygen atoms. The charge, found in the upper right, is -2. That means there are 2 extra electrons. These extra electrons enable this ion to gain an octet of electrons for its atoms. This polyatomic anion has a name of carbonate, and it always has this formula and a charge of -2. The other polyatomic ion is a cation, known as ammonium. Its formula is capital N, capital H subscript 4, which means there is 1 nitrogen atom and 4 hydrogen atoms in this polyatomic ion. The charge is +1 in the upper right. That means there is 1 more proton than electrons. Loss or gain of electrons in polyatomic ions occurs so the atoms can be more stable and usually obtain an octet of electrons. You won't be responsible for counting electrons in polyatomic ions, but I just wanted you to have a sense of why they form. Table 3.2 in the textbook has a list of common polyatomic ions. It includes their formula and charge, their name, as well as where we find them in our everyday life. Be aware that some polyatomic ions have more than one name that is accepted. So, as you are searching for names on this table, don't ignore what is in parentheses. You do not have to memorize this table, but it will definitely help you if you are familiar with it. The more familiar you are with polyatomic names and formulas, the easier it will be for you to name and write the formulas of ionic compounds. It's important to remember that polyatomic ions have constant charges.